this first question, as with all these type of practical based questions, you must read all the information you're given to help you answer the question, because often there's details in here that will really help your thinking. It wants us to complete this figure to show how to measure the volume of gas given off. 2 marks. 1 mark if you've got this bung with a delivery tube, and the second mark, here I've got an upturned measuring cylinder, which is full of water, and the bubbles will force the water down. I could also have drawn a gas syringe, in which case I don't need any of this water. So as I said, 1 mark for the delivery tube, and then 1 mark for the measuring cylinder, or 1 mark for the gas syringe. Okay, next one tells us the reaction is exothermic. Remember, that means it gives out heat and therefore is going to make the surroundings hotter. Explain in terms of bond breaking and bond making why a reaction is exothermic. So what we need to say here is that bond breaking takes energy in. So the breaking of bonds, energy needs to be given. Bond making is where energy is released. So if you've got a reaction that's exothermic, then the energy released as bonds are made is greater than the energy taken in when bonds are broken. There are 3 marks, so you're going to get 1 mark for stating these 2 facts and 1 mark for saying why it's exothermic overall. Okay, I've got a 6 marker. Again, please take the time to read all this information. The question wants us to explain, in terms of collisions, how the results affect the size, so we've got to talk about size, and the concentration of this reaction. So we've got some data here. You must use this data to help you. And as you can see, the data shows that if we use just the small lumps, when the concentration is higher, the volume of gas is greater. And it also shows, you would keep the concentration the same and look at the small against large lumps. Small lumps produce more gas than the large lumps produce. So let's get some points down here. So I'm going to deal with the lumps first. Result shows that small lumps react faster than large lumps. Small lumps have a larger surface area. So remember, the smaller the piece, the larger surface area. And if it's got a large surface area, there's more room for collisions to take place. There's a greater surface area, greater chance of those collisions taking place, and therefore the reaction will go faster. If we look at concentration, so to explore concentration, we pick the same size. So for example, small, you could have picked the large and compared both results. As the concentration of acid is increased, the reaction goes faster. And that's because there are more particles in a specific volume, and therefore there's a greater chance of successful collisions, and the reaction goes faster. So you want to pull it together, you can say that the faster reaction, or the fastest reaction, will be the small lumps with highest concentration. If you count it up, I think there's 10 bullet points there. So all I've done is count the bullet points and then look at how many marks that's equivalent to, and then give yourself a mark total for that particular question.